This is my vector word problem. So the word problem is, Melanie takes off her shoes and throws it at Nora, who is lying down, at a velocity of 13.4 meters per second at 33 degrees. Keep in mind that Melanie is 5 feet and 6 inches tall. How long does it take for the shoe to hit Nora? How far away was Nora from Melanie? So based off this word problem, what do we know? Like, what information can we get out of the word problem? So here it is again. And what we can get out of it is the velocity, which is 13.4 meters per second. And we know that the shoe is thrown at a 33-degree angle. And we also know that Melanie's height is 5 feet and 6 inches. And what we're trying to figure out is the time and the distance between Nora and Melanie. So I made a chart for the vertical and horizontal components, and this can help us figure out what we know, or like what we know and what we need to know. So we already know the vertical displacement of Melanie's height, which is 5 feet and 6 inches. And we also can infer that the vertical acceleration, is negative 9.8 meters per second squared, because it's a free fall problem. And the acceleration for the horizontal component is also 0. So of course we have to make a drawing so we can figure out what we need to find. So here's Melanie, and she has the shoe, which is being thrown at the angle, and there's me. So we know that the velocity is 13.4 meters per second, and we have the degree labeled, and we also have the height labeled. So we have the drawing and we have the chart, which can help us later on. So first things first, we have to convert all necessary measurements. Since the word problem has Melanie's height in feet, we need to change that to meters. So converting height to meters, what we need to do is, since it's 5 feet and 6 inches, I just made everything in inches so that it's easier. So 5 feet is 60 inches, since it's 5 times 12. And Melanie is 66 inches. So once you take 66 inches, you know that 1 inch is equal to 0.0254 meters. So then you can use unit analysis to figure out how tall Melanie is in meters. So you take the 66 inches, and then you multiply it by 0.0254 meters over 1 inch, and then the inches cancel out, so therefore the answer is 1.676 meters. And that's how you do the unit analysis for converting the height. So now we know that, as it shows in the chart, we added that the displacement of the vertical component is 1.676 meters. And then the next thing we're going to do is use SOHCAHTOA to get the horizontal and vertical velocities. And you can use regular SOHCAHTOA if you have one angle measurement and one measurement of the triangle that you make. So what I use is I labeled the horizontal one as X and the vertical one as Y. And in order to solve for X, you need to use sine, because so for the sine part of SOHCAHTOA, it's opposite over the hypotenuse. So I did sine of 33 degrees times 13.4 meters per second to get the horizontal velocity, which is 7.3 meters per second. And I did the same thing for the vertical one, and I called it Y. But the only difference is you use cosine instead of sine, since it's the adjacent measurement and the hypotenuse. So it's cosine of 33 times 13.4 meters per second, and the vertical velocity is 11.24 meters per second. So as part of solving the problem, as you see in the chart, we are able to label the initial velocity and the final velocity. So for the horizontal initial and final, it's both going to be the same, because the velocity doesn't change, or like the velocity stays the same in the beginning and the end. But however, for the vertical, the initial velocity is positive, but the final velocity is going to be negative since you're going down. So instead of 11.24, it's going to be negative 11.24. So now that we were able to get the initial and final velocities of both, we can solve for time using the acceleration equation. So we're going to use the information from the vertical column since we don't have enough from the horizontal column. And keep in mind the time for the vertical and horizontal is the same. Like, so, because like the shoe's going to hit me at the same exact time. It's not like the horizontal time is going to go faster than the vertical time because time's time. So I have my work on the side here. So what I did first was I wrote down the acceleration equation, which is final velocity minus initial velocity over time. And what I did is I changed the variables around so that time is by itself. So from the acceleration equation, I multiplied time on both sides, and I divided acceleration on both sides so that the new equation is time equals final velocity minus initial velocity over acceleration. And then I plugged in the numbers. So since we're using the vertical components, it's negative 11.24 meters per second minus 11.24 meters per second over negative 9.8 meters per second squared. So then I use unit analysis. Notice how the meters cancel out, and that since there's seconds squared in seconds, you get just s left, so that the new time is 2.29 because you divided negative 22.48 over negative 9.8. So now that we know the time, we can solve the last part of finding the horizontal distance. So what I did to find the horizontal distance is use the displacement equation. But notice we don't use the full equation. We only use the first part, which is VI times t. We don't use the second half, which is the acceleration part, because acceleration is 0, so it's just going to cancel out anyways. So you know that velocity is 7.3 meters per second, and you know that the time is 2.29 seconds. And now we're just going to use unit analysis. So you have 7.3 meters per second over times 2.29 seconds. The seconds will cancel out, leaving just the meters, and you multiply the two numbers together to get 16.71 meters, and that's the distance between Melanie and Norah. So we were able to get the time, and we were able to get the meters, so we solved the problem. Thank you for watching.